Hello and welcome to Mr. Tompkins EdTech. This series of videos provides work solutions for the GCSE Maths topic test produced by AQA. This video is Inequalities. Whilst these topic tests make excellent exam preparation and revision material, regardless of which exam board you're sitting, they are particularly useful for students studying for AQA as they are prepared by the same team who will be writing your papers in the summer. They will work best if you try and answer the questions yourself before watching the video. The topic test papers can be downloaded from this address, which I've also linked in the description below. They'll require a teacher account to access, so either ask your maths teacher to download and share them with you, or alternatively you can try pausing the video and attempting the question first before pressing play again to listen to my solutions. Check this playlist for all the other topics I've covered. I'm busy recording all of these topic tests, so if the particular topic you're looking for isn't there yet, why not drop me a comment below with your request and subscribe to my channel to receive notification of future uploads. If there is anything you don't understand, please ask in the comments. Make sure you mention the question number and try to be as specific as possible. I try to answer all questions promptly, especially around exam times. If you found the video useful, please do hit the like button, as this really helps me out. You might also like to check out my exam paper walkthroughs covering all the recent papers and practice papers from AQA. Just click on the card appearing at the top of the screen now. Okay, let's get started. Before we get started, I'm just going to show the blank question paper. So if you don't have a copy, you can now pause it and have a go at the questions first. And then once you're finished, you can start again and look at the answers. Okay. Question 1. Which inequality is represented by this solution? Okay, so you see you've got a line and it's running from 2 at one end up to 6 at the other. So our value of x must lie somewhere between the two. Now notice we've got an open circle at one end and a closed circle at the other. An open circle means that the end point is not included, so that usually goes with greater than signs or less than signs. A filled circle means that the end point is included, so you're going to get those as less than or equal to and greater than or equal to signs. Okay, so in this case, 2 is the boundary of this inequality, but it's not actually included, so x must be strictly greater than 2, and at the other end x has got to be less than or equal to 6, so it can be equal to 6. Okay, so which one is that? It is that one. Question 2. Circle the set of integer values that satisfy -4 is less than or equal to 2n, which is less than 2. Okay, now we want to get just x in the middle, n in the middle rather than 2n. And we can do that by, well, just the same way we do with equations, just to divide each part by 2 to get n by itself. Now this has got 3 parts. We need to divide each of those 3 parts by 2. So the left hand limit is going to be -4 divided by 2, which is -2. 2n divided by 2 is n, and at the other end I've got 2 divided by 2, which is 1. So n lies between -2 and 1. So on a number line, -2, -1, 0, 1. Now if I was going to draw it the same way as the question above, I'd have a line spanning between those. At this end I've got a filled circle, and at this end I'd have an open circle, wouldn't I? Now in terms of the integer values, they're the whole number values between those two limits then. So -2 is a value that we can have because I've got a filled circle on that end, which means that -2 is included. Any of the numbers in between will be. The other end of the limit, 1, that one is not part of my inequality solutions because my value can't actually be equal to 1. So the set of values then that are equal to that, or that satisfy that inequality, are going to be these ones here then, -2, -1 and 0. Question 3. The shaded region R represents solutions to 3 inequalities. Circle the correct inequalities. Okay, So we've got an inequality region, and so we've got a region, and it's defined by these three boundaries, the three lines that surround it. Okay, so first off, you've got the x-axis here that is one of the boundaries. What is the equation of the x-axis? The equation of the x-axis is actually y is equal to 0, isn't it? Because all the y coordinates are 0 on any point along that line. Another boundary of this region is this line here, the y-axis, and the equation of the y-axis is actually x is equal to 0. Okay, and then finally we've got this slant line that goes from 4 to minus 4. Now that's going to be in the form y equals mx plus c. I can see what the value of c is because it is 4, isn't it? So that's where it crosses the y-axis. So this is going to be y equals something to do with x plus 4. And what's the gradient? So between 4 and minus 4, 4 and 4 there, we've gone 4 units to the right and 4 units down. So every 1 unit we're going to the right, we're going 1 down. So it's got a gradient of minus 1. So then the equation of this line then is y equals minus x plus 4. Okay. So which one of these then, which are the ones we're talking about? So they're the equations of the boundaries. Now we need to decide which way round we need to do the boundaries themselves then. So let's take this bottom boundary then, y is equal to 0. Now we want the points above that. So we want those where the y value then is greater than or equal to 0. Okay. Let's take the left-hand one, x is equal to 0. We want the points to the right of that. In other words, we want their x coordinates to be greater than or equal to 0. And then finally, let's take this slant line, y is equal to minus x plus 4. Now you'll notice that each of these have been written with this value of minus x written on the other side. So adding x to both sides, you're going to get y plus x is equal to 4. So which way around does the inequality need to go? Is y plus x less than or equal to 4, or is y plus x greater than or equal to 4? Well, let's take a point, 1, 1, to test. So if x is 1 and y was 1, then 1 plus 1 would be less than or equal to 4. So we want it that way around. So we want the boundary y plus x is less than or equal to 4. Now all the boundaries are solid lines, so they include the boundaries themselves, which is why I'm using less than or equal to and greater than or equal to rather than the strictly less than or greater than ones. Okay, so they're going to be my three boundaries then. So x is greater than 0, greater than or equal to 0, y is greater than or equal to 0, and y plus x is less than or equal to 4. So which one is that then? That is this group here then, isn't it? Question 4a, solve negative 5 is less than or equal to 3x plus 1, which is less than 13. Now again, we can solve these very much like we do equations. I want to get, rather than 3x plus 1 in the middle, I want to just get x. So let's take 1 away from all parts. So there are 3 parts. I'm going to take away 1 from each of these parts then. So negative 5 subtract 1 is negative 6, and that is less than or equal to, well, my minus 1 and my 1 will cancel out, leaving me with 3x. And on the right-hand side, 13 take away 1 is 12. So I've got minus 6 is less than or equal to 3x, which is less than 12. Now dividing both sides by, or all sides by 3. Okay, so negative 6 divided by 3 is negative 2. 3x divided by 3 is x, and 12 divided by 3 is 4. So x lies between negative 2 and 4. Negative 2 is included because I've got like the it's greater than or equal to, but 4 is not included. So showing that on a number line then, I'm going to have my circles then at minus 2 and 4. I want all the values in between, so this line of values in between. Minus 2 is part of the solution, so I'm going to shade it to represent that that's part of the solution, but 4 is not, so I'm going to leave that one open. Okay, so that's my rather wonky number line solution. Question 5. Lee spent £12 making buns. He sells each bun for 80p. His target is to make a profit of more than £5. Set up and solve an inequality to work out the least number of buns he needs to sell to achieve his target. So we're told that Lee spent £12 making the buns. So if he wants to make a profit of more than £5, then he's going to have to make back £12 that he spent making the buns plus his £5 profit. So he's going to have to make £17 back then, isn't he, if he's going to make that sort of profit. So what we're saying is, let's say that for each bun costs him 80p. Let's say he makes X buns. Then his profit for each bun, his cost, well, the amount of money he's got coming in then is going to be 0.8 times the number of buns, in, isn't it? So 0.8x. That's the money he's got coming in. So if he's got X buns, 80p per bun, that's 0.8x he's going to have coming in. And we want to have that value to be greater than or equal to 17. Okay? Okay, so how are we going to do that then? Well, we need to make X greater than or equal to something, then, don't I? Okay, so basically I need to make, well, how am I going to get X from 0.8x? I can divide it by, well, 0.8 is the same thing. I'm going to rewrite that then as 0.8 is 4/5, isn't it? So basically, to get X back again, I need to times by 5 and divide by 4 then, don't I? Okay, so if I times the left-hand side by 5/4 and the right-hand side by 5/4, I should get X by itself. So then X is going to be greater than or equal to 17 times 5/4. What's that? 21 1/4. Okay, so he can't sell 21 1/4 buns, can he? So he's going to have to sell either 21 buns or 22 buns. 21 buns is not going to give him quite enough profit, so he has to sell at least 22 buns because it has to be an integer solution. So 22 is my solution. Question 6. Work out the largest integer that satisfies 2x plus 5 is less than or equal to 13 minus x. You must show your working. Okay, so you can treat these very much like equations. I'm going to add x to both sides to start with to get rid of that minus x there. So that's going to give me 2x plus x is 3x. 3x plus 5 is less than or equal to 13. And then subtracting 5 from both sides, I'm going to get 3x is less than or equal to 8. And then dividing both sides by 3, I'm going to get x is less than or equal to, well, it's 8/3. 3's into 8 go twice, so that's 2 2/3. Okay, normally I'll just leave it as an improper fraction, but actually it's helpful here because I want to know what is the largest integer solution for this value. So x has got to be less than or equal to 2 2/3. So the integer solution, which is the largest but less than that limit, is going to be 2 then, isn't it? 2. Question 7. Solve the inequality 2x squared minus 3x minus 5 is greater than 0. Now, normally if you were solving a quadratic, you would be looking to factorize, wouldn't you? And we're going to be doing the same thing here. I want to know what two brackets multiply together to give me 2x squared minus 3x minus 5. Now I've got 2x at the beginning, which means I must have 2x here and x here, which I multiplied together to give me 2x squared. I've got a negative 5 on the end, which means that one of my values must be plus and one must be minus. and the factor pairs for 5 are, well, there's just one factor pair. It could be it's 5 and 1, isn't it? So I've either got -1 and +5, or -5 and +1. Now the way the order that I put them in the brackets makes a difference when I've got a 2x and an x. If I put the 5 here and the 1 here, I could get 2x times 5, which would be 10x. Take away 1x would be 9x, which would not be right, so it can't be that way around. Let's try it the other way around. So if I put the 5 here and the 1 here, then I'd get 2x times 1, which would be 2x, and I'd get 5x, and when I get the difference of those, that will give me the 3x that I need. Okay, so which way around does it need to go with the signs? I think I'm going to make the -5 negative. That's going to give me -5x, and that's going to give me +2x, which should give me the -3x that I'm looking for. So my solution is 2x minus 5, x plus 1 is greater than 0. Now imagine that was a graph. It would be some sort of quadratic, wouldn't it? So it would look a bit like this. It would have 2 roots. Where would those roots be? You get those roots where your 2 brackets are equal to 0. So if I've got y equals 2x minus 5, x plus 1, then I'm going to get one solution, or one root, when 2x minus 5 is 0. In other words, when x equals 5 over 2, or 2.5, and the other one I'm going to get where x is minus 1. So looking at this graph then, this point on the left must be -1, and this point on the right must be 5 over 2, or 2.5. Okay? Now we want the area of this graph then that is greater than 0. Where is this graph greater than 0? We want greater than 0, greater than 0. So this graph is greater than 0 when the graph is above y is equal to 0, this section of the graph. And which values of x give those areas? Well, it will be from that point onwards, or from this point in this direction. So I'm going to have 2 possible regions. I'm going to have x is less than -1. That gives me this bit over here, look. And I'm going to have x is greater than 5 over 2, which is going to give me this section up here. Okay? So that's my solution. X is less than -1, or x is greater than 5 over 2. Now, it doesn't say to sketch this, but I do recommend that you draw a sketch of your quadratic and do it this way. Otherwise, it's quite difficult to get the inequalities the right way around. Okay, let's move on. Question A. On this grid, show the region represented by x is greater than 2, y is greater than 1, and 2x plus 3y is less than or equal to 12. Okay, so we've got a region and it's being described by 3 boundaries. So I'm assuming this is going to enclose some space, and we need to identify that on the grid. So let's take this one line at a time. X is greater than 2. Okay, now where is the line x is equal to 2? X is equal to 2 is a vertical line, isn't it? If it's x is equal to something, it's going to be a line parallel to the y-axis, and x is equal to 2 is the line passing through x is equal to 2. Now we actually want the inequality x is greater than 2, strictly greater than 2. So I need to show that on my graph as a dotted, sort of a broken line. Okay, if you use a broken line, it means the points on the line are not included in your region. Okay, so you use a broken line for strictly greater than and strictly less than, and a solid line if it's greater than or equal to and less than or equal to. So that's my line x is equal to 2. Okay, we'll worry about which side of the line we're looking for in a minute. Let's just draw the 3 lines themselves first. So y is greater than 1, Now I know the line y is equal to 1 is a horizontal line through the point y is equal to 1. Oops. So I'm going to draw a line here, and again I'm going to use a broken line because it's strictly greater than 1. It's not greater than or equal to. Okay, so oops, I can draw a dotted line, kind of a broken line there. Okay, so that's my line y is equal to 1. Okay, and finally I've got a slant line, haven't I? I've got 2x plus 3y is less than or equal to 12. Now let's have a look at the related line. 2x plus 3y is equal to 12. Just going to rewrite that in the form y equals mx plus c, so I know a little bit more about the line. So 3y equals minus 2x plus 12. And then dividing both sides by 3, I'm going to get y equals minus 2/3 of x plus 4. So I know then that y-intercept is going to be at 4, and I know the gradient is going to be minus 2/3. So it's going to pass through the y-axis here at this point, and it's going to have a gradient of minus 2/3. So for a gradient of m, which is minus 2/3, remember that's changing y and that's changing x, isn't it? So for every 2 units you go in the direction of y, you're going 3 units in the direction of x, or you're going minus 2 units in the direction of y. So you're going 2 units down for every 3 units across, basically. So if I go 3 units across from that point 0, 4, so if I go 3 units across and 2 units down, it's going to take me to that point. And if I go another 3 units across and another 3 units down, it's going to go through that point there. So that's what my line is going to look like. Now this line is, it tells me that it is less than or equal to. So I'm actually going to use a solid line for this line rather than a dotted one. Like that. So that is the line y is equal to minus 2/3 of x plus 4. Now you could also plotted that graph using the table of values, so that could have worked as well. So you could have just picked some values of x and calculated values of y to go with it and plotted those on. Either way, we've got our 3 boundaries now. Okay, so you can see that we've got a little kind of triangle shape in the middle, which I'm assuming is the region that we're going to be talking about. Okay, I'm assuming it's going to be this bit in here in the middle of those 3 boundaries. Just want to double check that. So x is greater than 2. If you remember rightly, this is the line x is equal to 2, this vertical line here. So greater than 2 is going to be the values to the right of that line, which seems about right. Y is greater than 1. So we've got the line y is equal to 1 here. So it's going to have to be above that line. And finally, 2x plus 3y is less than or equal to 12. These sort of points are the kind of hardest to see which side of the line you want. You can just take a point actually on one side of the line and sub it in and see if it's true or not. So I could take the point 0, 0 for instance, and sub in 0, 0 and see if it's true. And if it's true, then we're on the right side of the line. Okay. So if x is 0 and y is 0, is 0 plus 0 less than or equal to 12? Yes, it is. So yes, it is that area there. So that is our region we're looking for here. Okay. Well, that's that. I hope you found the video useful. If you did, please hit the like button and consider subscribing to my channel. Also, check out the playlist on the right for more topic tests, or the one down below for past papers. See you again next time.